this project we have started in collaboration with two companies from Israel. One of them is the NDrip Solutions. This company has supplied us the entire microgravity drip irrigation system that is installed here as a demonstration. The idea is to educate our farmers, show them a working system that can potentially save some water. The other advantage of this system is that since it is a gravity fed system, so we do not need any electricity. So it saves some money associated with the power also, which may be a very small quantity when we are talking about 1 or 2 acres, but when we start talking about hundreds of acres, that can potentially become significant. Then we also have a collaboration with another Israeli company. The name of that company is Tal-Ya, and these companies have provided us with some plastic trays. And the way those trays are oriented or designed, that any rainfall that falls near the plant, all that water is diverted towards the plant. And then since these trays cover the soil, therefore, number one, evaporation around the plants is less. At the same time, the weeds do not grow. Because of the trays, there is usually a slightly warmer microclimate, and that certainly prevents any weed development near the plant area. And once there is no weed around the plant, there is less competition for water. So this is known as the microgravity drip irrigation system. That essentially means that we do not need any extra pump or any other sources to pressurize the system. And the system operates on a very small pressure, that is usually less than 100 centimeters. So for that purpose, we have some containers where the water is initially stored to create a head, which is very close to and around 100-120 centimeters. And under this pressure, the water can actually flow through all of these drip pipes. The other important feature of these drip pipes is the way the drippers are designed. So these drippers, the way they work on the reverse flow system. So instead of water entering into the pipe and coming out of the dripper directly, water is sort of a backflow. So water fills the pipes and then it backflows through those drippers and comes out, and that is very important for reducing the clogging. We also take some additional precautions by also applying the hydrogen peroxide with the irrigation water, and we only need a very small amount of 2% hydrogen peroxide, but this hydrogen peroxide dissolves whatever the algae is in the water. And as you know that we have a big problem of brown algae in our water here in Las Cruces. So hydrogen peroxide will dissolve it, and therefore this algae simply comes out of the drip system without clogging it. So the funding for this project is provided by the Center of Excellence in Food and Agricultural System, also known as CES-FAS, Nakayama Professorship. And all the material for this installation of the system, all the drippers, all the pipeline, trays, everything were provided by the NDrip and the Tal-Ya Solutions, these two Israeli companies. So on this project, we have one research assistant. His name is Adam Gonzalez. He is responsible for all the irrigation, maintenance of the system, and as well as collecting soil and plant samples. He will eventually also become a graduate student and do a master's using the data generated through this project. Then we have another student who is a joint PhD from China Agricultural University. His name is Cheng Liu. And Cheng Liu's job was to develop a low-cost data logger which can transmit the soil moisture data wirelessly. Why do we want to do this? Because there are commercial data loggers available, but those are very expensive. The cost of a commercial data logger could be anywhere from $2,000 to $4,000. What Chang has done here, Chang has used the Arduino based system, and he is able to build a data logger which is not only very small, it requires a very small battery which can work for almost like 6 months even without recharging it. And but he has also come up with a very small solar panel, and that solar panel recharges the system, and therefore we should not worry about the battery life for the entire growing season. The other advantage of this data logging system is that it's not only it is low cost, but it can send the data to a centralized location, and which is we are using a Raspberry Pi, but somebody can always use a computer or a laptop if he or she wants. And from that location, the data is directly transferred to a server. Currently, College of ACES is in the process of building a server so that all of the data can be transmitted to that server. And then Chang has also developed a small program by which you can log into that website, and you can actually see what is the moisture content of the field at that time. Because when you are trying to improve the water use efficiency of your crops, one of the critical aspect is when to irrigate. And when to irrigate, that question can be best answered by collecting the soil moisture content data at a regular interval. And this system which Chang has developed, that website can be accessed by anybody, anywhere in the world, and somebody can, looking at that data, you can say when it is time to irrigate. And at that time, system can be cranked in, and you can irrigate and wait until your system is showing you back. Many people use different criteria to irrigate, but a very generally acceptable criteria is 50% depletion, which is also known as the management allowed depletion. So when your moisture content goes down by 50%, that is the time to irrigate. But if you do not want to stress your crops, you can always select a depletion of 30% or 40%. So the significance of this project is that southern New Mexico is considered as semi-arid environment. Our annual rainfall is very close to 230 millimeters, which is really small, right on the borderline for arid systems. The most of the agriculture is sustained through the surface water which is provided by the EBID. But we know that for last 15-20 years we are under severe drought, and therefore EBID is not able to supply all that water they are required to provide to the farmers, and therefore we have to use the groundwater to supplement the shortfall in irrigation systems. So therefore there is a big need for us here to not only conserve the water but use it much more efficiently. So drip irrigation system provides us an opportunity to control how much water, when to apply, and therefore we can certainly increase the water use efficiency of the crops. So if we apply the water near the plant roots, so that we can certainly decrease the wastage of water either due to evaporation or due to the water going down below the root zone. Because we know that pecan is one of the largest crop here, probably the second to alfalfa, which is grown in our state. Chili is also a very important specialty crop. New Mexico is very famous for its chili production and different chili products, and that was the main reason why we selected pecan and chili for this project. So we have collected a large number of soil samples. We have collected plant samples, then we have separated the roots, the shoot, the leaves and the chili pods. And essentially what we will do that we are not only measuring the total biomass, measuring the size and weight of the chili pods, We are also identifying the marketable chili as well as the total biomass. But we are also going to look into the iron concentration of like for example the sodium, calcium, and all the micronutrients and macronutrients in each of the component of these plants. So far what we have seen with our data that when we irrigated chili using the microgravity drip irrigation system, we are seeing that our yields are comparable to any other farm in Leyendecker which is under furrow irrigation system. And we have applied at least 100 millimeter less water as compared to the furrow irrigation system. So with this smaller amount of water, we are able to see the same yields. The data analysis is still ongoing, and probably early next year I will have a much more information to provide you with once we have all the analysis done. On an average, the cost of putting a microgravity drip irrigation system is somewhere between $600 and $700 per acre. And if you compare it with the pressurized drip system, those systems are 2 to 3 times more than the microgravity drip system.